Now, whenever I have unlike denominators, okay, whenever I have to get denominators to be the same, the first thing I want to do with any of these is to figure out what do I have and what am I missing. So like if it says the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. So with each of these, if I have 4x squared minus 16, I'm going to factor everything out first. So I'm going to basically have, I'm going to make one, okay, red. So if I have 4x squared minus 16, factor everything out. You're going to factor everything on the bottom side first. I'm not really worried about the top so much as I am the bottom, okay, or the denominator spot. So what can I factor out of 4x squared minus 16 before I even start? A 4. So if I have 4 times x squared minus 4, can that factor anymore? Two numbers that multiply together to give me a negative 4 and combine to give me nothing. So then the one in red, I have 4 times x minus 2 and x plus 2. If I do the same thing with 6x squared minus 24x plus 24, what can I factor out of everything here? A 6. So I have 6 times x squared minus 4x plus 4. Can x squared minus 4x plus 4 be factored? Are there two numbers that I can multiply together to give me a positive 4, combined to give me a negative 4? Negative 2 and negative 2, right? So x minus 2 and x minus 2. For me to find the least common multiple, that means I need the red one and the yellow one to match. That means everything needs to match. That means that if I have however many parentheses I have of something in it, they need to be the same. It's basically like, what does one have that the other one does not? Like I have a 4 and a 6. What number is common between both of them? How much? It's got to be bigger than these. 12, right? Okay. The factors are right, like as far as the 2, but I need numbers like I need 4, 8, 12, 16, 24, so on, 20, 24, so on and so forth. So it's like if I'm going to do this, I'm going to have, like to get the numbers to match, like I would have to multiply this one by 3 and this one by 2. Right? So then as far as the common part, it would be a 12. The numbers and the factored part out, like especially with the numerical value or the constant, whatever's out there, or the coefficient, those are usually the hardest out of anything. Everything else, for the most part, is fairly simple with the fact that it's like, what do I have? Like, what am I missing out of the red one that I have in the green one? Like, what's the red one missing? Basically from everything here and everything here. What's the red one missing and what's the green one missing? Right, okay? Because I have to have the same amount. So like the red one is missing an x minus 2. The green one is missing an x plus 2. If I have two x minus 2's, then the other one has to have, everybody's equal. Okay? Everybody has to be the same. If this one has 3 green M&Ms, then every other person has to have 3 green M&Ms. Okay? If that person has 4 red Skittles, then everybody has to have 4 red Skittles. Okay? One can't have something that the other one doesn't. Okay? We're equal opportunity here. Every rational is going to get every single part of the denominator. Okay? And I don't care what you've got to do to make that happen, but that's what has to happen. So then my common denominator, my least common multiple, would be 12, x minus 2, x minus 2, and x plus 2. Because the green one had 2x minus 2's. Good question. Does that make sense?
So then why wouldn't there be 3x minus 2? Because the red one.
The red one has 1, so it has to get 1 more. Right? The green one has 2x minus 2, so now they both have 2. 3 and 4 is 12. 2 and 6 is 12. So they share that.
Oh.
Does that make sense?
Yeah.
So the 3 and the 4, 2 and the 6, they both have 12 whatever. Okay? The red one had an x minus 2 and an x plus 2. Well, the green one, no, it has another x minus 2. It's like little brother, little sister, right? Well, he has this toy, so I want that toy. Okay? So the red one needs an x minus 2 because the green one has 2 of them. Well, the green one doesn't have an x plus 2 because, or the red one has an x plus 2, but the green one doesn't, so it has to get that one as well.
Okay.
Does that make sense? So then if I have 7 over 9x squared plus x over 3x squared plus 3x. Take your time, factor anything out. I can't do anything with the first fraction. Okay, the first fraction is just going to be 7 over 9x squared plus what can I factor out of the bottom down here? 3x. So then I have x plus 1. Now, what I will do a lot of times here is I will write these in different colors. So I have, what is the first one missing that the second one has? An x plus 1. So that means that the top and the bottom, x plus 1 and x plus 1. What is the second one missing that the first one has? Well, I have an x, 3x, right? Okay, because what's 3 times 3? 9. What's x times x? X squared. So then the second one is going to get a 3x and a 3x. So now do both fractions have the same denominator? Okay, do both of them have an x plus 1? Okay, do both of them have a 9x squared? Yep, because 3x and 3x is 9x squared, right? So everything that I did on the bottom, I did to the top. That's why if I have a 3x here and a 3x there, that's why I have an x plus 1 and an x plus 1. Okay? So once I get that, then I'm just going to leave it as 9x squared times x plus 1. Here's why I don't put everything together. I'll put everything together on the top, but the bottom I'm not going to. Okay? The top is kind of the hard part as far as I've got to put it together, and then I'm probably going to have to end up taking it apart to see if anything can cancel. So if I have 9x squared and x plus 1, what can x not be here? -1 and 0. Right. the top side, not that it's that difficult, but it definitely is going to be where you're going to do a little more of your work. What's 7 times x plus 1? 7x plus 7. What is x times 3x? Plus 3x squared. Now, I'm going to have 3x squared plus 7x plus 7, and then 9x squared times x plus 1. Now, before I call this one good, I need to check, always check to see on the top, can I factor 3x squared plus 7x plus 7? Well, your easy way of doing this is going to be to do it this way. Do 3 times 7, so that's 21, right? Can I multiply two numbers together to get 21 and combine to get 7 somehow, some way? Nope, 3 and 7, there's no way I can get 7 out of that, or 21 and 1. Okay, so it's not going to factor. So then all I'm going to do is just tack on my restrictions of x can't be equal to -1 and x can't be equal to 0. So with the division, I'm going to factor. I can factor out a 2, and then I have an x minus 1, and then I have x plus 2. Minus. If I factor the bottom side here, I have two numbers that multiply together to give me 3, combined to give me a -4. So x minus 1, x minus 3. -2x minus 1 on top. What is the first one missing that the second one has? X minus 3. So I'm going to have to multiply this by x minus 3 and this by x minus 3. What is the second one missing? A 2. So a 2 and a 2. So then my denominator is just going to be, I'm going to leave it as 2. I'm going to have x minus 1 and x minus 3. I need to multiply x minus 3 and x plus 2. So x squared, -3, positive 2 is a -1x. -3 and positive 2 multiplied is -6. Now, with a subtraction problem, what I would suggest to you to make this easier is to multiply everything. Since it's a 2, multiply everything by -2. So what's -2 times -2x? Positive 4x. What's -2 times -1? Positive 2, right? That way you don't have to really change the signs, okay? Or maybe you just distribute, maybe you just change the sign of everything in there. But the addition, usually students don't have any trouble, because just add it. Subtracting is the problem because they forget to change the sign of whatever's behind it. Okay, so in something like this, I would either turn it to a positive and change one set of the signs, or in this case, just multiply everything by a -2. So then the last thing that I want to do, or first off, what are my restrictions? My fault. Just 1 and 3. Because there's no x right here with the 2. Okay? If there would have been a 2x, then it would have been 0. Okay? So the bottom's just going to stay the same. I'm going to have 2, I'm going to have x minus 1, and I'm going to have x minus 3. Top side, I'm going to have x squared plus 3x minus 4. Now, can the top side here factor? Yes. So if it can factor, what I would tell you to do, or what I would, instead of rewriting everything, just write what it factors to above it. You know what I mean? Let's make this a little bit easier on you, so you don't have to completely rewrite everything. So plus 4 and minus 1. What's going to cancel? The minus 1, right? So then that way, that just saves you a little bit of time and effort. So the bottom side is just going to be 2 times x minus 3. Top side is just going to be x plus 4. My restrictions that I have written down there are not going to change, and 1 and positive 3. Obviously, if you have to factor something on the top, it's going to take you a little bit longer. Okay? And obviously, the more that you have to multiply, the more that you'll have to change things.